Hi, y'all. So this week we are going to be talking about making decisions with probability and kind of designing some experiments or simulations to help make decisions, and then also different ways that we can use some area models. You'll notice that in our notes today, I'm not pulling straight from the book only because our book moves relatively slowly, and with home learning, I still want us to cover all the things that we need to cover, and the pacing of the book just isn't going to work for us. So we're going to pick and choose bits and pieces. And so investigation 3, all of investigation 3 talks about making decisions with probability. So the example we're going to talk about right now is Harris's sides with whatever lunch or dinner he's having, right? I'm always trying to get veggies in him. He always wants cheese. Cheese crackers, mac and cheese, cheese sticks. Kid just loves cheese. So if I created a simulation, right? If I made a spinner and I said, okay, Harris, if we spin it and it lands on cheese, you can have cheese. And I racked this one right here. What is the theoretical probability that I'm going to get my way and he's going to get veggies? It's still just 50%, right? If it's a perfectly even spinner, it's a 50-50 chance of whether or not I'm getting veggies into that kid. Scratch that. If we move on to the second spinner over here, here's where maybe mom could get a little tricky. I noticed that there are 3 sections of the spinner where he could get cheese, and there are 3 sections of the spinner where he could get veggies. Again, but without actually doing the experiment, just thinking about theoretical probability, is this still 50-50? It's 3 sections and 3 sections. Something that I notice is that 2 of these sections are larger than the others, right? So with this guy, really what we're looking at is 1, 2, 3, 4, 5/8 of the chance that he'll get the veg, with only 3/8 the chance that he'll get the cheese. While it might have at first glance looked like, there was an equal opportunity with this second spinner, there was not. He's more likely to get the veg than the cheese. If he were old enough to understand spinners, I might give that a chance. We are now going to go ahead and take a look. Let's see here. Sorry guys, this is moving not the way I want it to, but just bear with me. We are going to watch a sweet video together to take a look at another option for an area model. Here we go.
I think I finally figured out how to solve my morning clothing dilemma. I'll just flip a coin to decide whether to wear the polka dot or the plaid pants. Heads for polka dots, of course. Tails for plaid. And I made a spinner to help me decide which shirt to wear. The purple is my favorite, so I gave it 1/2 of the circle. The green striped is my second favorite, so it gets 1/3. And the blue is a little loud, so just 1/6 for that shirt. I can use a square as an area model for probability. The square looks like this. First, I list the pants on the top and give each of them half of the area, since each pair has a 50% chance of being selected. The left side is for my shirts. I made the height of each area proportional to the probability of each shirt. 1/2 for purple, 1/3 for green, and 1/6 for blue. Now I can see all of the possible combinations, with an area proportional to the probability of getting each outfit. Let's give it a whirl and see what I'm wearing today. Well, I guess style shouldn't be left to chance.
So we're going to go ahead and do our own version of that. Let's imagine that we were doing a similar situation here, a similar experiment, but rather than pants and shirts, let's just say we're flipping a coin to decide, am I going to take a shower or not? Heads, yes, I'll take the shower. Tails, no, I won't. And then we've created a spinner here, and if it lands on blue, I'm going to wear jeans. If If it lands in the gray, it's the sweet spot. I'm going to wear sweatpants. And if it lands in the purple, I'm going to wear my fancy pants. Let's go ahead and, like he just talked about, create an area model for that. All right, so just along the top here, we've got our heads and our tails, right? Our shower versus no shower. And then along the side, we've got to break apart our types of pants, right? But before we can do that, we need to figure out what are we looking at. When I look at our spinner, I see that it's been broken into eighths. So that's what we need to do on here. So 1, 2, 3, 4, 5. That is sevenths. That is annoying. We're going to pretend like that is just perfect, okay? So it's now been broken into eighths, and let's go ahead and make it match. So I've got 3 of the eighths are purple. So 1, 2, 3. You see that 3 of our eighths are purple. 4 of our eighths are blue for jeans. 1, 2, 3, 4. And then there's that one beautiful gray line there for sweats, right? So if I asked you, hey, what is the probability that I am going to get to not take a shower and wear sweatpants? Like, when am I going to get to have the laziest day? Well, to not wear a shower, not take a shower is tails. So that's going to be on this half, and the sweatpants are right here. So what are we looking at there? We're looking at 1 out of a total 16 possibilities. So there's a 1/16th chance that if I were flipping a coin and spinning my spinner, that I would get to not take a shower and rock sweatpants. Let's try a different one. Let's say I wondered, all right, well, what is the chance that I'm going to shower and wear my fancy pants? Shower is going to be on the head side, and fancy pants are purple. In that case, we're not just looking at one of these, we're looking at 3 of them, right? Because there's 3 purples on that side. So if I'm going to shower and wear my fancy pants, there's 3/16 because there's 3 purple, 1, 2, 3, out of a total 16 possible boxes. Okay. So let's do one other quick review because I've heard from a couple of you that kind of using like a tree diagram was a little bit tricky. Let's talk about fancy pants and not showering, or fancy pants and showering in that scenario. So our first thing that we could do is we could flip a heads or we could flip a tails. And then after we have done that on our spinner over here, right, there are 8 possibilities. So we've got to have 8 branches off of each of these. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And then for each of these, we need to label what the possibilities are, right? There are 3 chances that it will land on purple. There are 4 chances will land on blue. 1, 2, 3, 4. And there's 1 chance will land on gray. And then same down here, purple, 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 blue, 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 and gray. Well, what is the chance that I'm gonna take a shower? That's heads. And then wear my fancy pants, that's purple. Well, it could be that one, or that one, or that one. So again, it's 3 out of a possible 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 3/16 of a chance. And again, this is theoretical probability because we are not actually doing, the experiment here. All right, guys, I hope this is helpful.